Welcome to Mr. Greenstein's Geometry, and we're in Chapter 11. We're going to talk about a 11.1, the circumference and the arc length. So circumference is the distance around a circle. Consider that we have a regular polygon. Let's try a square, and we're going to inscribe it inside of a circle. And then we're going to increase the number of sides of the polygon. And if we do that, you notice that it fits more snugly each time that we increase the number of sides of the regular polygon in the circle. So actually the polygon is turning into a circle. And what we found is the ratio of the perimeter, which eventually turns into the circumference, over the diameter approaches this number we call pi, and 3.1415, and it's a very, very long number. If you use just 3.14, you're not giving it justice. You have to use a lot more digits, and that's why we use calculators with the pi symbol. The circumference is the diameter times pi, but more commonly it is 2 times the radius times pi. So we know it's pi times diameter, but the one that we use most is 2 pi r. The arc length is a portion. It's just a portion, so it's just a part of the whole circumference of a circle. So what we do is we use the arc in degrees to find the length. If I have an arc of AB, which goes from here to here, I have that over 360. So it's part of the whole circle, times the circumference, which would be the whole circumference, is equal to just this arc length here. And of course, circumference is 2 pi r, so this is the formula that we'll be using to find arc length. In this case, we have a couple examples. For A, we have 8 centimeters, and we can find the arc length from A to B by using the radius and the angle, the central angle. So what we're going to do is we're going to first calculate the circumference, which is 2 pi r, which is 8, and then multiply that times 60 over 360. And that is going to equal the arc length AB that we want here. And the value that we should get is 8 pi over 3. And that's the length from A to B. Now let's try the circumference of the circle Z. The circumference of circle Z, since we know this angle and we know how much arc there is for that much angle, we're going to use the circumference formula with the angle. So we know that 40 degrees over 360 times the circumference is equal to 4.19. And if we cross multiply and solve that out, we find that the circumference is 37.71. Now let's look at C here. We have an arc angle that we want to find the angle of this. We have the arc length, which is 44 meters, and we have the radius, but we want to find the angle from STR. So to find that, we're going to use the angle itself. That's the angle RTS over 360 degrees. And we multiply that times the circumference, which is 2 pi r, So 2 pi, and the r is 15.28. And that is going to equal 44 meters. So when we solve this for the angle RTS, the angle RTS is going to equal 165 degrees. Now let's look at a real world problem. We have a running track where people are running around this track, and their straightaway is 84.39 meters on either side. And then we have a semicircle on either side here. The semicircle, if I put this semicircle with this one, it would have a complete circle. We're going to use the inside track, which is this 36.8, which is the red track in the inside here. I'm coloring it blue right now. So we're going to use that inside track to compute the length of one lap. To do that, we're going to take the circumference of the circle that has a radius of 36.8, so 2 pi r, which is 36.8. And we're going to add in 2 of these straightaways. So there's a straightaway here and there's a straightaway here. So we're going to have 2 of those. So plus 2 times 84.39. And when we add all that together, we get the perfect number 400 meters. So one lap around the track is going to get you 400 meters. What you should do on your own is calculate what it would take to go, what would the distance be if you went around the outside track, which has 44.202 meters as its radius. And the straightaways are, of course, going to be exactly the same on either side. So compute that on your own, and we'll talk about it tomorrow in class.